The European Space Agency is investigating the possibility of setting up solar arrays in space in the hope that access to 24-hour sunlight will help to overcome issue of energy intermittency on Earth. As part of the Solaris program, the European Space Agency is looking into whether space-based solar power could meet Europe's clean energy need as early as 2030s to help the continent reach its net zero targets. It joins the space agencies of several nations, including the US, China and Japan, in exploring SBSP, which mostly relies on technologies that have already been proven to work here on Earth. The space agency said this is not science fiction. The fundamental technologies are understood and are already being demolished on Earth and in space today. Solar farms would beam down power from space. SBSP would work by capturing solar radiation in space where the intensity of sunlight is much higher than on the Earth's surface and available 24 hours a day with no disruptions from nightfall or cloud cover. The ESA envisions there being massive Earth-orbiting solar farms which could be launched on low-cost, reusable launchers such as Starship currently being tested by SpaceX before being assembled in space by robot. These huge solar arrays would collect sunlight for transmission to a receiver station on Earth in the form of either microwaves or laser beams. The Earthbound receiver station would then use either photovoltaic cells or an antenna to capture this energy and convert it into electricity that can be delivered to the grid. The idea for SBSP has been around since the beginning of the space race, when it was actively investigated by NASA and found to be promising. The ESA Solaris program is currently in a preparatory stage, having been founded in November 2022 by the ESA Council to lay the groundwork for potentially launching a full development program in 2025. The ESA says that if SBSP were to be successful, it would solve some of the key problems standing in the way of full transition away from fossil fuels. Transitioning to clean energy is an urgent imperative, and Europe has committed to achieving net zero emission by the year 2050. But this will be extremely difficult if we rely only on existing renewable and low carbon energy solutions, as intermittency of supply, pressure on land use, scalability and toxic waste limit how quickly and effectively existing energy sources can be rolled out. According to the ESA, space-based solar power provides a continuously available, inexhaustible, sustainable, and scalable source of energy that could not only help to fight climate change but also build up energy security. However, there are still many engineering and policy challenges that would need to be overcome to make this ultimate energy source a reality as early as the next decade. The agency is also asking organizations to assess potential risk to the health of humans, animals, or plants in the vicinity of receiver stations, as well as how the beams will interact with ionosphere, the atmosphere, and the environment. The embodied carbon of deployment and potential impacts of beam interference on aviation and ground infrastructure are further areas for investigation. The science is sound, the engineering is feasible, and the economic feasibility is soon demonstrated by the upcoming Starship from SpaceX. Starship may make electricity from SBSP collectively priced to fossil fuels. But other novel transportation methods such as space planes, electronics accelerators, or in orbitators might make the electricity cheaper than even terrestrial solar and wind. In 2020, Naval Research Laboratory tested a power beaming satellite in space, and its Air Force is planning to launch a further test satellite dubbed Arachne in 2024. Meanwhile, China has an SBSP ground station and the test facilities in development and is planning to launch a demonstrator satellite in 2028 that will test out beaming on various targets and will have a 10 kilowatt power output. Japan is also developing SBSP through its space agency JAXA and tested power beaming from satellite to a ground receiver in 2015. The country is set to test roll out solar panels on the International Space Station this year. Thanks for watching this video till the end, and do subscribe to the channel to get the latest update on construction videos.